are still working in section 2.1. So as I said, the features that we can add that will give us more information about the data are the midpoint, the relative frequency, and the cumulative frequency. These definitions and their related formulas are found below. A midpoint of a class is found by using the formula below. You take the lower class limit and the upper class limit of one class and divide it by 2. In other words, you're finding the average of those numbers. The relative frequency is the portion or percentage of the data that falls within a class. To find it, you're going to use this formula. Relative frequency equals the class frequency divided by the sample size. And right here, you'll notice that we've introduced more symbols. Class frequency, again, we represent frequency with the letter F. Sample size is the number of pieces of data in our data set, and we always use the letter N for that. So notice here we're getting even fancier, and I have written that N, the sample size, is always the sum of the frequencies. As we saw in the last example, that gives you your total number of pieces of data. And last, the cumulative frequency of a class is the sum of the frequencies of that class and all previous classes. And when you finish your cumulative frequency column, the last class will be equal to the sample size N. So let's take a look at this in action. We're going to do example 2 from the book, which asks you to use the data from example 1. So I've copied over that table. We're going to begin by finding the midpoint of each class. So to find the midpoint, you just find the average of the lower and upper class limits. So I'm going to take 155 plus 190. I'm going to divide all of that by 2, which is going to give me a decimal. And it turns out to be 172.5. You're going to do the same thing all the way down. Add the lower and the upper, divide by 2, and report the midpoint number. The reason midpoint is helpful will be a little bit clearer to you later on. I'm going to go ahead and compute the rest of the values. All right, now that that's done, the next thing we're going to calculate is our relative frequency. The formula for the relative frequency is take the frequency of the class and divide it by the sample size. Now, just a reminder, our sample size N came from adding up this frequency column and totaled 30. For the relative frequency of the first class, I take the frequency of the class, which is 3, and I divide it by the sample size, 30. I'm going to get a decimal, which I will record, 0.1. Repeat for the rest of the classes. Take the frequency of 2, divide it by 30, and get a decimal. And I'm only going to write down a portion of this one, so I'm using that approximately symbol because I don't feel like writing decimals forever, and it's really not necessary. All right, I'm going to continue with that. All right, now these numbers might not seem particularly insightful to you until you realize what they really are. These are the proportion of the pieces of data that could be found in each class. Now, 0.1 is a fine number. However, usually instead of decimals, relative frequencies are more easily understood as percentages. So you should be familiar with the idea of taking a decimal point and moving it 2 places to the right to convert it to a percentage, or just multiply it by 100. Either one will have the same effect, and you'll realize that this is really a relative frequency of 10%. So 10% of the pieces of data on the list fell in the first class. The next one, moving the decimal, is equivalent to 7%. Then we have 17%, 20%, 23%, 13%, and 10%. Okay, so generally speaking, we can leave it in the decimals as long as your brain understands how to interpret them as their corresponding percentages. And as a little check, when you add up the decimals in this column, add up the frequencies divided by the sample size, it should equal 1, which represents 100% of the data. So now I'm able to answer a question like, where does most of the data on the list fall? I look for the highest percentage, and most of the data, 23%, falls between 299 and 334. Okay, so that's relative frequency. The last one we're going to talk about in this video is the cumulative frequency. Now, living in Buffalo, New York, you should be familiar that when it snows, they start reporting the snow accumulations. So it's related to that word. Cumulative means you're adding as you go. So snow falls, then we add another inch, we get another inch, we get another inch, and we report the cumulative total, which might be 10 inches. When we're talking about cumulative frequency, you start with the amount in that class. So the frequency of the first class was 3. You add to that all the previous classes. Now there aren't any, so the first one just transfers across, essentially. Now, for the next cumulative frequency, you take the data in this class and you add to it all previous classes. So 2 plus 3 is 5. For the third cumulative frequency, take that frequency and add it to all of the previous. So 5 plus 2 plus 3 is 10. And the numbers are going to keep getting bigger and bigger. They're going to accumulate. So I add on 6 to 10, I get 16. I add on 7 more, I'm at 23. I add on 4 more, I'm at 27. And I add the final 3, and that's 30. And from up above here, the definition said the cumulative frequency of the last class should always equal the sample size. And that is the case here. We had 30 pieces of data, and the last number in my cumulative frequency column is 30. That's an introduction to a basic method for organizing data.